Number 9 on vector spaces. First of all, this says you have a matrix. A and B can be any real numbers. 0 and 2 are obviously 0 and 2. So if we let matrix A be something like 3, 1, 0, 2, B be equal to 2, 1, 0, 2. The only restrictions are A and B can be anything. 0 and 2 have to be in the bottom row. So if we add A and B, we get the two matrices, 3, 1, 0, 2. So we get our sum. 5 and 2 are any real numbers, A and B. 0 is 0, but we're supposed to get a 2 in the 2, 2 position. We got a 4. So number 9, property 1, closure for addition, does not hold. So 2 by 2 matrices with any two numbers in the top row, 0 and 2 in the bottom row, do not form a vector space. Let's continue. Number 10 on vector spaces is the set of 2 by 2 matrices in which the 1, 1 and 2, 2 position are equal. This turns out to be a vector space. Let's look at number 10. These are, again, 2 by 2 matrices. And I'm going to rewrite them in a different way because it says A equal D. So if A equal D, then D and A are the same. So I'm going to write it as AA, where A, B, C are any real numbers. Now, as we look at this, if we think about that in the diagonal, they're simply equal elements. If I add two matrices with equal elements there, I'm going to get equal elements. If I multiply by something, I will get equal elements. If you go through all 10 of the properties, nothing can change AA, whether we're adding, multiplying, no matter what we do. Since we have two elements that are the same on the diagonal, there's nothing that can change those. So number 10 is in fact a vector space. So let's look at number 11. Number 11 is simply ordered pairs, but we have non-standard multiplication in which C times any ordered pair is C times the first ordered pair, 0 in the second component. So no matter what happens when we see circle times, we have to do this operation, not standard. So let's look at property 7. And we'll begin, we will let U equal U1, U2, and V equal V1, V2. So on our left-hand side, we have C circle times U plus V, and that will simply be equal to C. I'll just do the substitution here. U1, U2, and V1, V2, which is then equal to, well, we got to add first because they're in parentheses, C circle times U1 plus V1, U2 plus V2, and then we'll actually do the multiplication, which will be C times U1 plus V1, 0, which is really then CU1 plus CU2 V1 rather, comma, 0. So let's look at the right-hand side. And the right-hand side is then C times U plus C times V, which is then equal to C times U1, U2 plus, I forgot my time sign there, plus C times V1, V2. So in this case, we're going to do the multiplication and then add. So we get C U1, 0 plus C V1, 0. Adding those, we get C U1 plus C V1, 0, which is the same as the left-hand side. So property 7 holds. So let's continue with 11. Remember, our property is C circle times XY is CX comma 0. So property 9 so C times D times U. And that simply is is supposed to equal to CD times circle times U. So let's take our left-hand side, and we have C circle times D circle times U. But if U is U1, U2, we have C circle times D times U1, U2, which is equal to C times du comma 0, d1 u comma 0. And then we take that times c, that ordered pair du 0. We again end up with cd u1 comma 0. So far so good. We look at our right hand side, and our right hand side says that we just have cd circle times u, which is just cd times u1 u2, which is cdu, because we multiply the first component by the constant, but we get 0 in the second one. We see that the two sides match. So the left-hand side equals the right-hand side. Property 9 holds. Let's continue with property 10, which says that 1 times this u should be the same as u. So on my left-hand side, I have 1 circle times u, which is really 1 times u1, u2, which is equal to 1 times u1, which is u1, 0. The right-hand side, I'm supposed to get u, which is u1, u2. They don't match, so property 10 fails. Our set V is not a vector space. Let's look at one more example. Let's look at number 13. 13 is simply ordered pairs xy in which both components x and y are both greater than or equal to 0. Okay? So for example, 1, 3 is in there. 2, 5 is in there. 0, 0 is in there. 0, 1 is in there. 5, 0 is in there, etc., etc. If we check properties 1, 2, 3, they all hold. Let's go to property 4. Property 4 is our inverse. So it says if 2, 5 or xy, because x and y are positive, is an element, so that's going to be my vector u, right? So if u is in there, the opposite of u has to be in there, so it adds to 0, 0. But the opposite of u is -2, -5. But my x is less than 0, my y is less than 0, so property 4 fails. So 13v is not a vector space. One last problem. 14. We're looking at ordered pairs with multiplication defined as c times xy is equal to the constant times the second coordinate, and then the constant times the first coordinate. So what we want to notice is we've reversed our multiplication. So we can either do a specific, pick an ordered pair, 1, 2, 5, 9, negative 4, 3, whatever that is, or I'll do it in general. So properties 1 through 5 all hold because it is standard addition. Addition has not changed, it has not been referred to, only multiplication. So we look at property 6. Property 6 holds because we do get an ordered pair. CY, CX, it's an ordered pair. So it is a member of R2. So we look at property 7. Property 7 holds, but you should work this out on your own. Property 8 holds. Again, you should work this out to make sure that it does work, but property 8 holds. Property 9, C times D times U is supposed to be equal to C times D times U. Well, if U is our standard, let's move it instead of U1, U2, let's just make it our XY. So let's do our left-hand side. Our left-hand side is C D times XY. And when we multiply a constant times this, remember it says we reverse those. So we get CDY, CDX. Let's try our right-hand side. So this time it says we're going to take C times D after we've multiplied D times U, which is XY. All right? So D times XY, all right, I still have my circle times, I'm not doing anything with C, times the ordered pair, dy, because remember we reversed the order. So now I still have one calculation to go, so that's equal to C times, but it says when I multiply, I reverse the order. So when I reverse the order this time, I get CDX, CDY. But wait a minute, when I did the left-hand side, I got them in the other order. So property 9 fails. So V is not a vector space.